f is a function given by this expression, and you can see mod function involved in this expression. We write L equal to left hand limit of fx, as you can see, at 0 negative, and r is right hand limit, it is at 0 positive. Then which of the following is true? L exists but r doesn't exist. L exists, L doesn't exist but R exists. Both L and R exist. Neither L nor R exist. So we have to test left hand limit and right hand limit for function fx at 0. Keep remember, for this function, continuity of the function doesn't ask, because of function is not defined at 0. So how can we find limiting value of the function and exact value of the function at the point we doesn't find, or we can't find? So to solve this problem, we only find limit, either left hand limit or right hand limit. For left hand limit means L, and is given by limit x tends to 0 negative fx. So fx is given by the structure x plus mod x, and within bracket 1 plus x divided by x, and in numerator you can consider sine 1 upon x. So we, whenever mod function involve, always try to resolve mod function for positive value and negative value. So I can write, when x is positive, so mod will be x, so 1 plus x divided by x into sine 1 upon x. For negative value, mod x is minus x, 1 plus x divided by x, sine 1 upon x. This is the structure of fx for x greater than 0 and for x less than 0. Further, you can simplify. For this x, or you can take x as outside, so it will cancel out by this one. So left term will be 1 1 plus 1 plus x, and sine 1 upon x is also there. Second term, this term will be 1 minus 1 minus x into sine 1 upon x. So what we have? We have for 2 plus x sine 1 upon x, and this one cancel out. So minus x sine 1 upon x. On further simplify, I can write 2 into sine 1 upon x plus x into sine 1 upon x, and for this I can write simply x sine 1 upon x. So this is defined for positive value, this is defined for positive value, and this is for negative value. Now find left hand limit and right hand limit for function. So L will be limit x tends to 0 negative, fx will be limit h tends to 0 minus x, or I can write 0 minus h sine 1 upon 0 minus h. So for this, what we have, limit h tends to 0, h into sine 1 upon minus h. So sine minus x is equal to minus of sine x. So I put minus here and make it positive. So this is somehow look like as minus of limit h tends to 0, h into sine 1 upon h. As sine function is bounded, you can observe the graph of sine function, and h is tending to 0. So after putting limit, this is look like 0 into some bounded value, because of sine value of this sine is oscillate between two numbers, means 1 and minus 1. So 0 into some bounded number will be 0, means limit of left hand limit exists and is equal to 0. Now work on right hand limit. So expression for right hand limit is this, as I oval the part by red marker, 2 sine 1 upon x plus x sine 1 upon x. So r will be limit x tends to 0 positive fx, and this one is equal to limit h tends to 0, it will be 2 sine 1 upon x, 2 sine 1 upon x plus x sine 1 upon x. So you can observe this limit will not be 0, means it doesn't exist. How? Because of whenever you apply limit concept here, it will form h into sine 1 upon h. So h is tending to 0. So sorry, limit of this part will exist. This h tends to 0, 0 into some bounded function. So limit of this part is 0. Limit of this part is 0, but limit of this part is not equal to doesn't exist. How? 2 into some bounded value. But sine have no fixed value, as we tending to 0 from right hand side. So we have many values, but it is bounded by 1 and minus 1, we can see, but no fixed number. So limit of this part is not exist, not exist, but limit of this part exist. So finally r doesn't exist. So what we have, L exists and R doesn't exist. So which one option is true? Option A is L exists but R doesn't exist. So option A is correct.